Yeah.
Praveen, yeah, cloud, it's buzzword nowadays, and everything for on-premise, it's moving to AWS or Azure or say other Salesforce and other cloud platform. So it's
Hmm.
providing SaaS, PaaS, all kind of services it's providing,
Hmm.
and that to at minimum cost that they are promising,
Hmm. Yeah. So at the
and
high level, this is what it is.
we do not have to take care of all kind of hardware and stuff like warehouse and data center like stuff. So it's easy
Absolutely.
to go migrate on that, and yeah.
Absolutely. Anybody else?
Yeah, Sandeep here. So technically, it is virtualization, but on the term of cloud, it's you don't need to manage your the physical hardware, the and infrastructure and data center, right? So you are purchasing services from the cloud provider as per your need. For example, compute network, software as a service or database as a service, and you can deploy your infrastructure on their uh, premises or their data centers along with the
Yeah, awesome,
licenses cost.
awesome. Yeah, so can we define it in simple words like it is something about on-demand computing that we can subscribe and use,
Yes.
right? So that's where it all starts. Probably the roots of cloud were sown when the virtualization at the very basic level got introduced to the market, right? We had Microsoft Virtual PC, we had VMware, we had VirtualBox, where we could create the virtual machines and run parallel systems on the same hardware at the same time. Instead of shutting down the machine and booting into some other operating system or some other environment, uh, which requires lots of efforts and lots of time also. Uh, Using virtual machines basically provided us much better advantage because practically the machine, the base machine itself was never required to be shut down, right? This becomes very, very important aspect when we are testing the applications in different environments, correct? So virtualization actually got introduced there, and then with the changing requirements in the market, basically people thought that why not expand this capability, why not leverage this capability at a very, very large scale so that people can benefit more out of it. If the virtualization can happen on one machine, why not think about spanning it over the network of the machines? That's where the network-based virtual machines basically were introduced. The virtual servers were introduced, right? Like Hyper-V server came in, VMware server came in, then VirtualBox server came in, and then further moving on to the very, very large scale, basically that is where the cloud got introduced. Correct. Now, one of the biggest advantage that we get with cloud is some of the advantages you people already said, like we don't need to worry about the maintenance of the hardware, data center, warehouse, and all that, right? Second advantage that you spoke about was about the cost. Yes, but on the top, the main advantage that we get over here is scalability, which comes because of the virtualization only. My application, when developed, probably requires some set of resources in terms of compute. When I say compute, it actually is about how much processor power I need, how much RAM I need, how much data storage capacity I need, right? Putting it together, it is compute. So there might be a requirement at the beginning. But a simple question over here from my side is, does this requirement remain the same all the time throughout the lifetime of the application? Yes or no?
It's a no. It's a no because you may be deploying. You may want to enhance the features. So
Absolutely. And the requirement for enhancing the feature comes because of change in business needs. Am I right?
Yeah, yeah.
So you have to enhance because of change in business needs. Sometimes some security patches you have to come up with. Sometimes maybe while fixing some issue, the need gets changed for the compute, right? Uh, your data also keeps on growing because usually the business data never becomes stagnant, right? The data is always going to grow. It keeps on growing, 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 growing. So your algorithms also need to be adjusted over the time to accommodate the volumes of data that you have as on that particular date. Am I right? The queries that you write today, the algorithms that you write today might be working very fine for next 2 years, 3 years. But after 2, 3 years, when the data grows exponentially, the same algorithms may become the worst performing algorithms, worst performing queries. So you have to redevelop them or re-strategize them, sometimes re-architect them. Am I right?
Yes.
And that's where we need to understand the need for scalability. You need to upgrade your hardware with change in need of your software, right? So what are the different strategies when I talk about upgradation? The simple upgradation which comes to mind first is like, okay, I have a machine, which may be a server. I probably increase the amount of RAM that this machine has got. I probably install more powerful processor into it. Or if it's a server machine and if it supports multiple processors into it, I can put more processors into that machine. And similarly, I can increase the storage by adding on higher capacity drives. Am I right?
Yeah, correct.
Right?
Yes.
This is what we usually call as upgradation. Correct? This is something what we call as vertical upgradation. Is it unlimited? What I mean is, can we seamlessly upgrade one specific machine? I don't think so, right? Whether it is laptop, whether it is tablet PC, whether it is a workstation, whether it is a server hardware, there is a limit beyond which you cannot further upgrade it. You have to replace it. Am I right?
Yes.
Yes. But when it comes to the business applications, replacing is not an easy task, right? There is a cost involved. You need multiple levels of approvals. Plus, there will be some downtime also when you actually come up with a replacement server. It may be for a few minutes at times, but again, when it's a critical business, downtime of few seconds is also not something that we can actually accommodate. Am I right? Like if I talk about the applications being used in uh, space research or maybe healthcare, these are some mission critical kind of uh, business domains. Am I right? If banking goes down for 5 minutes, that's okay. People can understand. But health cannot wait. 5 seconds delay also can be fatal. Am I right? Yes. In such cases, what do we do? And what do we do with the existing set of hardware? Should we throw it away? We purchase it at a very higher cost. It's a server hardware we're talking about. So we cannot just throw it away, right? There are so many things already working on it. So instead of throwing it away, can't we think of having another server installed and which probably can take some load from the original server, wherein we can bring in the concept of load balancer. Now, whether this load balancer is going to be software based load balancer or hardware based load balancer, that is a different question altogether. But is it possible or not? Let me answer this. It is possible. Next question, which is more important, is it feasible and advisable to go for parallel servers along with load balancing solutions or not? Anybody?
Maybe for a limit.
And why do you think that it should be for a limit only?
Beyond some limit, it will be like difficult to we have to add different, not a single load balancer. We can have like different strategies, but that could be very
Yeah,
difficult
but
again.
say the next level would be bringing in more load balancers, right? Network of load balancer can
Yes.
be configured, right? But yeah, the strategy is something which can become a base strategy for us, right? Having parallel servers, having multiple instances of the application running, and having one or more load balancers in between. Am I right?
Yes.
Right? Say you guys are from Vodafone, right? Vodafone core business is everyone knows outside also. It's in mobile networking. Am I right?
Yes.
Right. Why do we have so many towers across specific area? Because there is a capacity which one tower can handle and which is limited. So what do? We have other tower and there is switching which is continuously happening, load balancing which is continuously happening. If one load balancer is not enough, we have more load balancers in that place. If one tower is not enough, probably we install another set of towers or maybe more transmitters. Am I right? And that's my point here. I hope everyone understands what I'm trying to say. Your existing hardware can be kept as it is. Your new servers can be introduced from time to time. As far as the same configuration is just delivering what we are looking for, we will probably keep on upgrading with the same set of hardware for the point where we realize that the same configuration going forward is not going to be enough. Probably the new servers can be brought in with better configuration, higher configuration also, which conforms to the modern requirements. And the older servers can be phased out gradually, if not immediately, because every machine has got a lifespan, say 5 years, 10 years, after which it has to be completely removed from the uh, overall system, right? So after that, probably we can phase it out. But by that time, the newer, better capacity hardware with better capability probably might have already taken place. Yes or no? This way, probably your downtime is going to be almost next to zero. I said almost because 100% I cannot say that. There are other factors also which may be responsible for downtimes at different situations. But yeah, it is near to zero only if you have multiple servers set up. If one server is down, there are other servers who are probably capable enough to take care of uh, the load which is coming in from different users from different places. Am I right? This kind of scalability is something what we call as horizontal scalability. Yes or no? And this is the biggest advantage that any cloud provides you. You practically need not worry where my server is, how many hardware systems are in place, because you are working on virtualization. You may have multiple server instances running on the same set of hardware. You may have multiple instances running on different other hardwares also, whose control at some level is with you as well. We have concepts of regions, we have concepts of zones. If you have worked on Azure, you might be already aware of availability sets and availability zones and so on. Am I right? So it's going to be important. When we are talking about cloud, we should be aware of the scalability as well, right? Regarding the cost gets cut down because of multiple reasons. We don't need to have servers. We don't need to have server means we don't need to have the civil infra also, the buildings and the server rooms and all that to maintain those servers, as we don't have servers. We don't need physical security staff for that. We don't need the hardware and network engineering team for that, because that is something which will be entirely taken care of by the cloud service provider, right? We probably need the admins, the system admins here as well, because they will be responsible for the upkeep of your applications and their deployments. Again, we are talking about SaaS, PaaS, IaaS, infrastructure as a service or software as a service or platform as a service. There is some level where you actually are going to take care of your virtual machines, if not virtual machines, which will be the applicable thing with EAS, IaaS, infrastructure as a service. Then with platform as a service, you need to take care of your application deployment environment and the application itself. And with SaaS, probably the least of the load comes to you, right? But we need some set of people for that. So staff also getting cut down. The civil infra is not required. That also saves cost. Along with that, the licensing also becomes easy. Usually, if you have your own hardware, the software that runs on those hardwares, basically the license for that needs to be purchased separately. Am I right? Be it the operating system or any other software running on that operating system. Yes or no?
Yes.
At the same time, if you go with platform as a service or software as a service, do we buy any licenses there? Do we own any software there? No. What we need is just a subscription. And having the subscription doesn't mean that we are actually paying. We pay when we use, just like the electricity bill that you pay for the electricity used at your home. If you use, you pay. If you don't use, you don't pay. Got my point? So what it brings in is pay as you go strategy. Now, whatever we have discussed till now, it's all about the cloud in general. It's not specific to Azure, except couple of terms that I use like availability sets and availability zones. Everything else is all about general cloud. Now, why Azure? That is something that will be answered in the upcoming slides. So to start with, what do we mean by getting started today? So there are a few things which we have already discussed, like why I should go for it, the cost savings that basically are going to be provided. So the first question you can see in first step itself is listed is how much cost I am going to save. Why not sit with a pen and paper and find out how much cost actually I'm going to save? It will be easy if you are the decision maker. Yes or no? I have my own server. So suppose I'm starting up the company and I need to set up my servers and everything. Simply, I need to find out how much investment I'm going to need if I'm looking for on-premises setup. And if I go with cloud, what cost I will be bearing. Direct comparison can be made. And if it is difficult, in that case, Azure has got a tool also, azure.com/TCO. TCO stands for total cost optimization. it actually does the real-time comparison and shows you how much cost you are actually going to save. Isn't it interesting? Yes or no?
Yes.
Then the next question will be, how do I migrate? The question will be why migration comes in. Everyone starts on premises only. Your application development doesn't happen directly on cloud. Am I right? So even if you are not having on-premises servers, the development is still going on the local devices. Am I right? Some basic servers you might have, development servers, I would say, which would be something like the uh, source control servers or something, right? At the very simple level, local Git repository you might have created on those, or maybe an alternative to that, right? So ultimately, the question will be, how do I take this application to cloud? How I get this application hosted on cloud? And ultimately, later on, how do I manage it from cloud? Yes or no? Then the second scenario is, I already have the application on premises. I want to migrate that. Third question is, if I already have the solution on cloud, but maybe AWS, maybe GCP, maybe some other cloud, I want to get done onboarded on Microsoft Azure. So azure.com/migration actually provides you the guidance about the same, which again starts with the total cost optimization, where you can actually compare and contrast what I'm paying to the other cloud service provider and what I'm going to pay to Microsoft for Azure. If you see the benefit, you decide on migration has to be done or not. If you see that migration has to be done, what all things I'm going to need to do, to get the migration done, right? How my application needs to be prepared for the migration. What are the prerequisites? All this is something for which the guidance will be provided by this azure.com/migration. And then the actual step starts, which talks about starting the migration itself. Now, when we talk about migration, it itself is a project, right? So start your migration project, and the ecosystem expertise over here can be then leveraged. Again, for which the guidance is available on azure.com/essentials. You can note down these URLs. Anyhow, uh, this slide is going to be shared after the session with you. The entire deck will be shared with you. So even if you don't make a note of it right now, it will be with you. You can just go through these URLs and check out the details. I hope this is clear. Any questions on this? So shall we proceed? Okay. So here comes the comparison between Azure and AWS. Why I chose AWS? Because AWS is the nearest competitor of Azure. The neck to neck fight is between these two providers only. The other cloud service providers are still far behind what Azure and AWS are at this moment. AWS, no doubt, is the market leader for now. Azure is quickly catching up with it, and it's pretty near to where AWS right now is, right? And that's why AWS got chosen. So this is something which actually talks about the same type of application requirements being supported by AWS. I mean, the backend services being deployed on AWS, and the same set of services being deployed on Azure, and the comparison in terms of cost which I'm going to pay or which I have paid has been the base for this, right? So definitely there could be some services where Azure is more pricier, where AWS is cheaper. Vice versa also is possible where Azure is cheaper and AWS is pricier, right? It is also possible that some services are at the same level. This keeps on changing. This never remains fixed because as the services gets enhanced, the entire cloud platform gets enhanced. They keep on revising their costing also from time to time. It's not a consistent thing. So we cannot exactly say that this service is cheap and this service is costly on this platform, right? And that's where that TCO, the total cost optimization tool, can help you because it gathers the real time information as on that time. Okay. But again, when we talk about saving the cost, it's not only about how much I'm going to pay for the deployment. It is also about the supporting things. When I say supporting things, means what? When I'm using some product, how much support I get. Say, for example, you purchase a TV. The cost is 50,000 rupees for X brand and 60,000 for Y brand. The first information is X brand is cheaper. I'll go with it. Yes or no? Where the features are exactly same, quality is exactly the same. Definitely my choice will be X. Yes or no?
Yes.
But then if I say I'm charging 10,000 more with product Y or TV brand Y, but I'm giving you 10 years of replacement warranty for no other additional cost. Whereas brand X is giving me 1 to 2 years of the replacement warranty only. Which one is better, do you think? Brand X, 50,000, gives you 2 years of warranty. Brand Y, 60,000 is the price, but gives you 10 years of unconditional warranty. Which one is better now?
Why?
Initially, I might see that the cost is 10,000 rupees extra, but with that, I'm getting more trust. Yes or no? I know that if anything happens in next 10 years, I can just get a replacement piece. Yes or no? And usually these days, the life of the TV itself is not more than 6 to 7 years. Within 5 years only, usually people replace the TVs. Yes or no? Because the TV sets develop some snacks for whatever reason. So is it important or not to see the other things also? Now, the same warranty in terms of software becomes what we call as support, after sale support. That's where Microsoft has got a very, very big team. They don't charge anything extra and provide you seamless support. As far as your subscription is active, your support is always there, right? Even if the support is ended, which is the case when the product is discontinued, Microsoft commits that 3 years of security updates will still keep on coming into your solution. So you have 3 years to decide what next, which next technology stack I should be moving to, which is good enough time, right? Usually the other service providers don't give this much leverage. They suddenly say that, okay, we have discontinued this. You have got 1 month or 2 months or maybe 6 months to migrate. Security updates, we are stopping. So before you migrate to the new solution or new system or new product, your product actually is vulnerable because new security threats keep on coming. And if security patches are not coming, updates are not coming, your application is going to be more and more vulnerable. Yes or no? If you need the support there from the other providers, you actually need to pay additionally so that they can give you the dedicated team for the same who will work with you or your team to provide you the security patches only for you. So that adds to the cost. Plus, if I talk about infrastructure as a service deployment, where I need to buy the operating system licenses and the other software licenses also, just like if I'm buying it in on-premises environment, the cost of the licenses here is discounted up to 40% also in some cases. If you already own the on-premises license, 40% discount you get on cloud. If you don't have any license already, still you are promised that you will be getting discount of at least 25%. So one level of cost saving comes in here as well. Plus, existing licenses on premises, which will be put on hold once you decide to migrate on cloud, are allowed to be reused on cloud once again with the Azure hybrid benefit. So they are not going to be wasted at all. Suppose I have two Windows Server licenses left with me, which I plan to use on two new servers for me, but eventually my company has decided that we will be going ahead with Azure based servers now. I can reuse those two licenses on the EAS deployment of the two new servers. Infrastructure as a service deployment of the two new servers. Got my point? Same thing graphically displayed on the right hand side of this slide. Just go through it quickly. If you need more details about this discussion, there is a link at the bottom right corner also, aka.ms/y5x more. More detailed illustration is there with audio visuals.
Hi.
Yes,
Is there any comparison? We have got a comparison with Windows as well as SQL Server. Is there any
yes.
comparison with Amazon App Stream 2.0 versus Azure Media Player G2?
See, very specific comparisons for all the services may not be available, but that's where the total cost optimizer tool can help you out. Right? I mean, this
Yes.
way graphically, it may not be available. If someone has done that in some of their article, they have mentioned it, you may have it. But yeah, the TCO tool is the best one to actually look at that because it gives you the real-time information. It queries the actual servers. What is the cost as on today, as as of now? Understood?
Yes. Okay.
Yeah. Okay. Now, looking at the title, we're talking about Windows Server. We are talking about SQL Server. Who is the actual maker of Windows and SQL Server products? Microsoft. Simple it is, right? Microsoft Windows and Microsoft SQL Server. Yes or no? And who is the cloud service provider for Azure? It's Microsoft. Now, Microsoft being the provider of all the three, definitely Azure will be the best destination for hosting any Windows-based deployments or SQL Server-based deployments because Microsoft own product are already well researched by them. They know those products very well. They are their own products, and they probably might have put their best foot forward to get the entire environment created on cloud. So integration with different applications will be much more seamless. Just like SQL Server works the best on Windows Server in on-premises environment also. Though we have SQL Server for Linux and Mac OS as well, but best performance and best security for SQL Server is available along with Windows Server and Active Directory configuration. Same way, Windows and SQL based deployments on Azure work the best on Azure. I mean, on cloud compared to Windows Server, SQL Server based deployment being done on the other third party cloud service providers. Understood? Plus the support that you get. You will be looking for support at cloud level, at Windows level, at SQL Server level from one single party only. You need not communicate with different parties. So it will be much more better experience. So whether it is related to the general administration or maybe backup, restore features, disaster recovery, identity management, anything, right? Also, Azure comes up with one SQL Server instance, I would say, uh, on the pass mode, which they call as Azure SQL Database Managed Instance. So when I say managed instance, what does it mean actually? It is managed by Azure. You need not worry about what is the virtual machine running behind it, or is it a physical machine which is hosting the server, or uh, how about the security of the physical security of the server? What about the logical security about the server? Anything you don't need to worry about. You just need to worry about what you want to deploy, where you want to deploy, and what will be the accessibility for it. This managed instance is already made capable of supporting the big data services, analytics, and machine learning, and artificial intelligence also. It's made for that. So it's architected for that. And ultimately, Microsoft already has got a deep trust with multiple enterprises because of their seamless support that they offer. Right. And as I said, the single vendor support is like if all of your softwares are from the same vendor, it becomes easy. If there are multiple parties involved, the coordination becomes a challenge. Right. And one more important point not to miss, reuse familiar skills and tool sets. So if you have worked with SQL Server on premises, working with SQL database managed instance on Azure is not going to take any new skill set or anything. You already know SQL, that helps. You already know Windows, that helps because the basics remain the same. Now,
Hi,
yeah,
sorry to interrupt. A
go
small
ahead, go ahead.
question
Yeah.
regarding the cost bit. Actually, we got migrated from on-premise to AWS in 2020,
Okay.
around March. So we have infrastructure like servers and all on
Mm-hmm.
AWS, and it was migrated from on-premise servers.
Mm-hmm.
But unfortunately, they are not using any scalability.
Mm-hmm.
So, like to like environment, they have almost set up,
Yeah.
but And for user base, they are using AppStream 2.0, and
Okay.
they are sensing a very large amount of cost involved.
Okay.
Like
So
our
what I
users and
understand is your deployment, the migration deployment has been something like lift and shift, right? Whatever you
yes, yes,
had in on-premises, you just replicated it on AWS cloud
right.
from physical to
So
virtual. That's the
yes,
only change brought in, with the
y-
identity management being changed to what AWS now supports. Yes.
right.
Now,
So
this is where
yeah,
the cost optimization has to be looked into. So it's not that I'm promoting Azure or something, but the thing is, when we do lift and shift, there are many things that we don't consider. Should we use this or not? Should we use that or not? Whether what I was using in the on-premises environment is suitable for cloud or not. Unknowingly, we keep on using some services which are not meant to be used on cloud, which actually adds to the cost. So it actually requires thorough analysis. And whether you go to Azure or not, the Azure cost optimization module can still help you. How you can optimize your cost on AWS also. Provided by Microsoft, but it's not meant to be used only for Microsoft. It can help you on any cloud in the world. Understood?
yes, yes. Thank you.
Right. So it will ask you some basic questions like what is your setup? What is your expectation? What you are doing? What kind of data you have? What are all features you have used? And then it will run its own analysis and will come up with the suggestions. Now, again, I said suggestions. It doesn't mean that you have to accept all. Some of them might not be suitable to your deployments, but majority of them, I guarantee, will be suitable. So you can just go through one with that. If that solves your issue, good enough. Otherwise, you still have the option. Yes, you can actually use this tool to compare and contrast any cloud service provider in the world. So it may come out that, okay, GCP is much better for this deployment. Just for an example, I'm saying. But TCO will give you the honest opinion. Understood?
Yeah, we have to carry out that TCO analysis, right?
Yeah, right, right.
Thank you.
So along with the TCO based analysis, you need to go through your deployment at your end also before you go with TCO. So what is your thought on it? Like what you have done, whether you think is it correct or not, whether whatever you have configured is correct or not. You make use of your pen and paper, make your notes, and then go through TCO and then compare the two results. And then take the best out of it. That will make more sense. Okay. Okay. So in short, we have already got the answer about why I should be migrating to Azure because of multiple benefits, especially if I'm having all of my application stack on Microsoft technology. Uh, like if I'm having .NET based applications, I'm having SQL Server based databases, I'm having identity management with Active Directory and all. My natural choice ideally is supposed to be Azure because Microsoft can help you in and out to get the best out of the platform with least possible cost, right? So that's something which is summarized over here in this slide, like unparalleled innovation with Azure SQL database management, managed instance coming in, Azure infrastructure as a service providing you I would say the entry level cloud features uh, where you can actually again go with lift and shift and then re-architect your applications to make more use of the PaaS services that Azure offers. And then the tool itself, Azure Migrate, which actually provides you the suggestion what you should be doing in the correct way, right? And then security. So we have got something called as Azure Security Center, just like we used to have Windows Security Center in Windows servers. We do have Azure Security Center, which scans all of your deployments, and looks for any vulnerability based on the industry standards. Gives you a complete detailed report along with suggestions what can be done to improvise. Provided, is there any improvement required? If all is well, then probably it just gives you all green ticks. Everything is good. That's a good news for you. But at times, with newer deployments, there can be some vulnerable configurations as well in place, right? So you have complete support, automated support before you reach the human support. The platform itself is much more capable to support you out, right? And then there are tools like Azure Sentinel, Azure Intune, and all. Then different offers that they come up with. So migration program is there, extended security updates we discussed about. 3 years of security updates are committed by them. And then the hybrid benefit, which allows you to reuse your existing licenses so that they are not uh, wasted, right? So by design, Azure is actually hybrid. The technology stacks, if we talk about, it all starts with Microsoft. It all started with Microsoft, I would say, because that's their own arena, first of all. Definitely, they must have tried and tested everything on their own uh, stack only. But when we speak about cloud, it cannot be limited to one stack. They also opened up and said that, okay, just like other clouds, we are open to host anything, everything on our platform. So you have not only Windows VMs in EAS, you have Linux also. Different flavors of Linux are available, like Ubuntu is there, Red Hat is there, SUSE is there, then Fedora is there, CentOS is there. You take the name and it's available, right? So that's something about the OS in EAS mode. Development stack, if I talk about, you have the full support for Java. Tomcat server support is also there to host the Java web applications. Then you have support for Python, you have support for Ruby, you have support for CGI Perl also completely with Azure App Services, which is the app hosting platform for web applications on Azure. Then we don't have the managed databases only for SQL Server. We do have managed databases for PostgreSQL as well, MySQL as well, which is from Oracle, and MariaDB as well. And the list is just growing. No wonder if someday Oracle also announces that it is available on Azure, or vice versa. Microsoft can announce that, okay, now our platform has got Oracle onboarded as PaaS service. So you have variety of the technology stacks to choose from in pretty easy manner. And with Microsoft's mindset of keeping everything simple with lots of GUI options available, it becomes very, very easy for the developers also to try and test the different services, get them deployed and started pretty quickly without putting in much effort and without knowing many commands, right? It actually wins there itself. Whereas other cloud service providers I've worked with, I've seen that lots of dependency on commands is there. Very less support for GUI based deployment is there, which makes things complicated for developers, right? And then you have the options like Azure Site Recovery, which is not only in case of disaster recovery, but it can help you with migration as well. And it's available very well with Linux also, not only for Windows. Database migration service on the same ground is also available for SQL Server, MySQL, PostgreSQL, even NoSQL as well. For NoSQL, they have Cosmos DB, under which there are 5, 6 APIs which come in. Like one is NoSQL API of Microsoft itself, which used to be called as Document DB in the past. Then we have support for PostgreSQL and NoSQL category as well. Then we have support for uh, Gremlin. Cassandra, MongoDB, all major NoSQL platforms are already supported under one single unified model, that is Cosmos. Containerization, very well supported. Dockers, Docker container registry of our own can be created pretty easily within just few clicks. Container instances can be created like that only. And then if you are looking for the complete microservices architecture based deployment to be done with container management coming in, where usually we go for Kubernetes service, whether on premises or on cloud, any cloud, usually Kubernetes is what is most popular. So we do have the AKS service, Azure Kubernetes service for the same. The entire Kubernetes platform we do have available here, which support Windows containers, which support Linux, all type of Linux containers as well. Even OpenShift container support also is available. The right hand side, the rightmost side, I would say, is all about the databases, SQL, NoSQL databases. So we already discussed about this, right? Cassandra, MongoDB, in Cosmos DB. Then Gremlin is there. Yes. All majority development stacks, technology stacks that are usually required these days, all popular ones are already there. And this list is also continuously growing. Some more scenarios which may not be required all the time, but in some specialized cases, we need to think of them listed here. Secure workloads, mainframe applications can be migrated, NetApp, NetScaler, SAP, SAP HANA, all applications can be put on Azure Cloud. How these are supported? So again, we have to go back to EAS, infrastructure as a service, where we talk about VMs, virtual networking, virtual appliances, and all. When I talk about VMs, we can have Windows servers, Linux servers, virtual desktop, VDI architecture. Then we have the app support with app services. So ASP.NET, Java, PHP, Python, Ruby, Perl, CGI, all available. For data, we have different types of databases, not only the traditional RDBMS or the NoSQL databases, but we do have support for big data services, big data analytics, other analytics platforms, and then AI and machine learning, along with cognitive services as well. And then the hybrid stack. So we have one option of Azure that we can have set up on premises infrastructure. If I already have my own data center in on-premise mode, I can actually take advantage of that to set up my own private cloud also. Azure has been made available by Microsoft for this with Azure Stack, which is an extension to the Windows Server operating system. Once installed and configured, your own data center can provide you all the services just like Microsoft Azure, the public cloud. And then it is completely supported with VMware as well. So whether you go with Hyper-V virtualization or VMware virtualization, it doesn't matter when you go with Azure Stack. It's your choice. Okay. Now coming on to the main point, the migration. So the first step definitely is assess your environments with Azure Migrate, which includes 3 steps that we discussed earlier as well: plan, get ready, and then adopt. So you have to assess your existing workloads, deploy the workloads, and then make them available publicly, which we call as releasing the workloads. That's a simple step that you have to go through. And this might be a repetitive model, right? Because there might be multiple applications or the servers that we might need to migrate. Here is the glimpse of some of the app service plan pricing tiers. As I said, the app service is basically the web hosting platform on Azure. When I say web hosting, web technology, which I disk is like .NET or precisely ASP.NET or Python, Ruby, CGI Perl, or PHP or Java-based web applications, anything can be applicable. And when I say app service pricing tier or app service plans, what it is? It's about the configuration that I will be using in the backend because app service itself is a PaaS service. Here we don't talk about the VMs. But without the machine, your application will not get hosted. There has to be some machine. And because it's on cloud, it has to be virtual only. There is a virtual machine being configured by you, maintained for you by the service provider. We have the choice as a user to decide what configuration we need. And accordingly, the price is determined. So this is the glimpse of the same. So we have web, mobile or API apps. We have the free tier also. We don't pay absolutely anything for this. Then there is a share tier. For dev and test environments, usually we go with it. Then basic tier is there, which also is used for dev test mainly, but with little higher configuration and with no limit on for how long I can use the compute because free tier is available for 60 minutes in 24 hours. Share tier is available for 240 minutes, that is 4 hours in 24-hour cycle. From basic tier onwards, there is no such cap. It's unlimited. Your VM access will be available 24 by 7 from basic tier onwards. Then you have the actual production workloads going in standard and premium tiers. And then very specialized applications which require lots of dedicated resources and it's probably resource intensive application. You might be looking for hosting it on a dedicated physical hardware rather than running on virtualized environment. There you go with the isolated tier. So how much storage space you get, how much compute you get, scalability is available in all, but if I talk about free, shared and basic, auto scalability is not there. Manual scalability is there. You have to manually upgrade. Auto scalability means where you can actually put some kind of checks, monitors, and based on which or based on the output of which you can actually configure some uh, logic which automatically provides you the scalability. So if the load is more, let's say the CPU is being utilized more than 80% for last continuous 5 minutes, I might want one more instance of my server to be created and the load to be shared with it. And then if I see that the usage is continuously below 25% for last 10 minutes, I probably want one of the instances to be reduced. So this is something which is available from standard tier and above, right? Again, there are some services like hybrid connectivity, virtual network connectivity, support for private endpoints, means the site may not be, I may not be looking to make it available to all. I may be looking to make it available only to the members of a specific virtual network. That's where we go for private endpoints, right? So that's what it is. Then compute type. Shared means there is no dedicated VM for you. There is a VM already created within which the applications of other third parties also might be running, wherein your application will also be hosted and running. Whereas from basic tier onwards, you get a dedicated virtual machine for you. Only your applications would be hosted in it. No one else will be able to host their applications into it. An isolated tier is completely different. You don't talk about virtual machines, you talk about physical servers. So that is isolated. And then the last row basically talks about pricing. Free, then $0.013 per hour. It's hourly calculated, right? So again, pro rata. If your application is up and running, your app service plan is active, then only you are going to be charged. Otherwise, you won't be charged anything. Basic tier, $0.075 per hour. Standard, $0.10 per hour. Even if I talk about isolated, it is just $0.40 per hour, where you are getting a dedicated physical server. Not very high, right? So this is what I was talking about, manual and auto scaling. Manual scale, here you have to use the slider to increase the number of instances. Auto scaling, you can create rules based on the inputs received from the monitors and checks. And whenever we talk about scaling, as we discussed, there are two types of scaling, horizontal and vertical. Vertical scaling is denoted by scale up, where you upgrade your pricing tier plan or app service plan, and scale out means number of instances you are increasing. You don't need to configure the load balancer also, Azure will take care of it. Isn't it interesting? For that load balancer, I need not pay anything extra. Just that if one instance is costing $10 for 1 month and I'm using two instances, I'll be paying $20 a month. That is it. And in reality, the second instance I may not be using for all 30 days. Aggregate, I might have used for 12 days only. So $10 plus $10 multiplied by 12 divided by 30 is what I will be paying. One instance will always be running, so $10 fixed. The second instance, $10 is the cost for the month, but I used only for 12 days out of 30. So 10 multiplied by 12 divided by 30. That's what I'll be liable to pay. Make sense or not?
Yes.
Then we do have another service on Azure that is called as Logic Apps, which can allow you to create the different workflows to get some automated tasks created over here. And it comes up with a rich library of pre-decided or pre-created tasks with an added advantage of being able to create a custom task also. You can have your RESTful APIs also linked in over here as a task. Right? So this can be used for some of the logic processing within your application, or it can be used for doing some backup task also conditionally, step by step. It can be for admin, it can be for development, it can be virtually for anything. So just like Microsoft Flow. Actually, Microsoft Flow has been derived from this only. This is the parent. Okay, moving on to the next level, where we'll talk about migration modernization strategies, projects and innovation. Here are the scenarios. You have your app, you have your data, you have your infrastructure. You have to migrate not only for the sake of migration, but you want to use the modern techniques and technology stacks to leverage the cloud, and to serve the modern needs of the businesses as well. So that's where modernization comes in, right? So on premises, what you have is your app, data, and your hardware. It all starts with lift and shift all the time, just like what you guys did. Lift and shift. Just replicate my application on cloud and then slowly take one module at a time or one small application at a time and see how this can be re-architected or refactored so that it leverages other cloud services also. Take full advantage. So that's where refactoring and re-architecting comes in. And this is the part of modernization. Probably my existing application is having some code to get something done, but cloud already has got a built-in service for getting it done. Why would I like to get uh, the custom code doing that for me? I might rethink that, okay, this is something being taken care of by a service already. Let that service do that job. It's already tried and tested at the very high level, right? With industry standards. So why not use that? Why not trust that? I will rather focus on the actual core business logic of my application. So I need to re-architect the application as well, right? And then slowly I move towards making the application more natively available for the cloud or more natively built for the cloud, which uses all cloud services only. So slowly from infrastructure as a service to platform as a service, I'll move. And then I can think of making the application more subscription based, where I have the next step to go with software as a service being made available, like Microsoft Office 365, Microsoft Dynamics 365, or Google Suite from Google, right? The lower section of this particular slide talks about what you will be using at what level. So lift and shift, the first part, rehosting, would mainly depend on virtual machines, virtual networks, virtual appliances. Probably then you will go for container-based hosts, right? Microservices, micro front ends will come in. Your app and data will be separate. Your AI and ML services will come in for analytics, right? And along with that, the most important part will always be applicable throughout whichever layer you are at, that is security and management of the deployment. So these are some of the commonly done Azure migration or modernization projects. Moving Windows servers, moving SQL Server, moving application servers like ASP.NET, PHP, Java, etc. Then the other databases hosted on Linux, open source databases, SAP, and maybe some specialized workloads also, like NetApp, NetScaler, HPC, etc. These are some of the commonly targeted application migration patterns. I have a setup on the left hand side and on premises with virtualization already being used. That virtualization may be something like with Hyper-V, VMware, VirtualBox, or maybe containers. Ultimately, I have line of business app running into it where I have a web application with app service layer, and then there is a data layer. I want to move it to cloud. Let's say Azure Cloud. App still remains LOB, but I don't need a separate virtualization layer here. Directly, my web and app layer can be hosted. To start with, I might target the Azure based virtual machines for both web and app layers and data layers. And then eventually I can target the app services, the PaaS service, right? App service for applications, app service for app layer, SQL Server or PostgreSQL or MongoDB or Cassandra, Gremlin for data layers. And to get this done pretty quickly, lift and shift, it should be as easy as said. I have the tool over here which can do this for me. I should not be forced to get this thing done manually. Take the entire environment from the on-premises and replicate it on cloud, Azure cloud, with the help of ASR, Azure Site Recovery Tool. And the advantage is the configuration also will be replicated. With least amount of efforts required, you will be successfully able to migrate your application. Now, as I said earlier, that when I say migration, it may not be necessary that I'm doing it from on-premises all the time. I might be going from AWS to Azure, GCP to Azure also. Right? So the left-hand side, you can take it like that. Understood? Here is the database migration service. ASR is for the overall deployment, whereas database migration service is pretty much targeted. And actually, these are subsets only. ASR has got app service migration tool. ASR has got database migration service built into it. That's what we will be targeting. So more benefits coming in with Azure cloud migration. Available globally with high availability services already being taken care of. 99.99% of SLA coming in, which makes it always available. Still they say highly available because 0.01% chance is there of a downtime. That builds the trust, right? And it's a completely hosted service, so available from everywhere. You just need good internet connectivity. Stable internet, if not very fast. Also, being available online, you have immediate access to the latest features. The moment it's released, it's available for you. The cycle is actually managed by the agile approach only. So every 3 weeks, which is a typical agile uh, sprint cycle, right? So you see the upgrades almost every 3 weeks. And highly scalable for teams of any size, from tens to thousands of people working within it. Also, pretty much compliant with different software stacks, different technology stacks, completely secure, follows all the modern security standards across different regions also, like European region these days is following GDPR, right? Every different region has got their own security standards. So it's custom made based on the regional requirements, based on which data center you're working with. Okay? Compliant and secured by design. You have got variety of tools available as the choice at every stage for every environment. For assessment, you have got Azure Migrate tool. Data migration assistant is there. SQL Server migration assistant is there. Data migration can also do the same job as SQL Server, but data migration assistant is more generic tool. It doesn't make difference between the different databases, even SQL or no SQL. Whereas SQL Server migration assistant is built for migrating SQL Server, very specific one. Then for migration, the actual migration, you have got ASR, Azure Site Recovery, database migration service, app service migration tool. There is something called as Azure Data Box also. And then for optimization, you have TCO, of course, and then the security optimization tools also, which actually takes care of security, backup, restore, monitoring, continuous monitoring. There is a tool called as App Insight, which does all the logging, has got all the support for the uh, analytics of the logs also. We have log analytics basically, and then cost management as well. Okay, so let's summarize what we discussed. It all starts with rehosting, where we use the term lift and shift. So basically, what that means is we redeploy the entire application stack, technology stack, redeploy, or we can also say replicate on cloud. Right. So here the advantage that we get with this is mainly the reduced capital expenditure. Your civil infra space can be actually saved. You can free up. Local data centers can still be maintained for maybe backup purposes or something, right? Or maybe doing something else. Quick return on investment is there with this. Then you have the next stage, that is refactor. Make some minor changes to take better advantage of cloud. Like, okay, for this particular job, I have this service, I'll use this. Instead of having my own code running or my own software deployed on that server, I probably have a ready-made service in PaaS mode. And then completely re-architecting the solution to take more advantage of the ready-to-use environments in PaaS mode. This may require little bit of redevelopment also. And then rebuild. So this will be complete redevelopment. Writing the entire application from scratch may be more suitable for the new applications which are being planned. With the cloud always being at the back of the mind. So that's why I mentioned as new code written with cloud native approach, where we can target the modern architectures as well, like microservices, micro front end, ultimately targeting the software as a service deployments as well. Understood? So some of the key elements to make sure that your migrations are successful is your planning has to be correct. So migration approach to be followed. Make use of the right migration tools for the same. Take advantage of the offers which are available at the time of migration. If your team finds it difficult to do the migration at their own, on their own, there are multiple migration partners available with whom Microsoft has already made the tie-up, right? They are specialists into the migration. They can guide you through. And then to build the capability on Azure, maybe trainings and certifications are also needed. So that's where people like and organizations like ours comes into picture. Very soon we will also be getting a migration partner certificate from Microsoft. So we will officially be a migration partner. So this is just a snapshot of the websites which are available. We spoke about TCO and Azure Migrate and all. This is the kind of stuff you will see there. Probably by the time I'm delivering this, the UI might have changed, the content might have changed as well, because there are lots of upgrades which keep on happening continuously. As I said, every 3 weeks you see something new. I'm sorry. Some more tools. Using reports from those tools is also important. So you get something like this: save up to 78%, save up to 68%. Some suggestions are there. Links also created how to do this, which tool I should use for this. Completely integrated environment we have on azure.com itself. Right, and this we also discussed, like now all the regions of Microsoft have been designed in such a way that they have already kept all their local security policies in mind. Like for European region GDPR, for example. With high availability support, continuous monitoring support with app insights and data insights and all that. Full automation support. So scripting support is there, where scripting can be done with Bash or PowerShell script, anything that suits you with your existing skill set. Right. So once again, here comes the Azure Migrate to assess your environments. To rehost, you have Azure Site Recovery. Architecting or re-architecting for high availability in Azure. So at different levels, the different SLAs already mentioned. On the rightmost side, we can see the number of regions which are supported as on today by Microsoft. We do have support of region pairs also. What is region pair? If your main region is region 1, within which all of your deployment is there, because of some natural calamity or some natural disaster, your data center goes down entirely, along with the supporting zones also. Your data can still be safe if you have enabled the region pair. It may be probably at the other part of the earth also, right? And now Microsoft is planning to get regions created under sea and in space also. So virtually your data will be possible to get lost once the space, I mean satellite based data centers are enabled by Microsoft. So here we have the migration and disaster recovery features. Azure to Azure migration and recovery is available. Along with that, you can have your on-premises servers also being backed up for disaster recovery on Azure. Maybe you have not made your mind yet to migrate. Still, the VMware deployments on premises, Hyper-V deployments on premises, or any single server deployments that you have on premises also can be backed up to Azure and restored whenever required. While restoring, you have a choice: restore to on premises or restore to cloud itself. Again, when it comes to restore to cloud, it's not mandatory that you have to restore to Azure cloud only. You can restore to virtually any cloud. That makes it stand apart. Some key capabilities of ASR tool. You have continuous log-based replication, automated protection and replication is there, right? Continuous failover tests are also conducted behind scenes. You can have a workflow based recovery plans created, conditional plans with continuous monitoring again integrated with those workflows. Then you can set up the centralized monitoring and alerting with notifications and all. Right. So some of the important uh, features of Azure Site Recovery. Here comes the disaster recovery. So that's a standard thing only, nothing new in this. If you understand disaster recovery, this is easy. And this is the multi-region design. You have exact replica created in secondary region. Access primary will be granted to the users to the primary region only. But in case if primary region is available for whatever reason, the secondary region becomes your primary for the time being until and unless the primary region doesn't become active again. So definitely there is some traffic management required with some load balancing features also built into it. So there is traffic manager. Another example for the same. Now, one change I see here is within regions also, we can configure availability sets. What are availability sets? We can make sure that there are replicas of our deployments created within the same data center on different set of hardwares. When I say there is a data center actually is made up of multiple physical servers. So I can make sure that my replications are on different physical servers. The virtualized images only, but on different virtual servers. So if one box is having a trouble, there is another instance running on another physical box from where it will get served. So my application becomes more resilient with it. Okay. So any questions? So I hope you have enjoyed the session here. As this was more of a curtain raiser session here, I didn't get deep into the topics. We spoke about the tools, we spoke about the features which are available, some advantages, disadvantages here, right? What are the different capabilities that we have on Azure platform, right? So usually to take this deep, we have 3 to 4 days of workshops also conducted from time to time. Uh, for which there are two options, like the workshops that we conduct at our end, basically where we invite the nominations from different organizations. And if there is a project team requirement, uh, the request can be put through your L&D manager as well. And there will be a dedicated session in that case conducted in uh, Vodafone premises or maybe online as per the need. So for that, probably my team will be happy to serve you if there is any requirement. And my colleague Preeti has already shared the link for the feedback. Just spare 2 minutes and share your honest feedback there, which helps us to improvise the sessions. If you want anything to be added or removed from the content, that also is something which you can put in your comments in the feedback itself. Meanwhile, if there are any other questions from anyone, please unmute yourself and ask.
There can be a dedicated session on AWS, which will depend on the L&D team's involvement, right?
Yeah, yeah.
Uh,
So we
okay.
do sessions on almost everything that IT industry needs. It can be starting with the soft skills to any technology stack, any platform you ask, we are there.
Okay. Okay. Thank you. We'll connect.
Thank you.
Thank you all.
Vikas, you there?
I think someone is recording this session. Can they stop recording and they can
Yeah,
share
this
the end?
this I'll ask my colleague to share with you because directly it won't be available. Uh,
Yeah.
Teams has got the organizational policies, right? So we will put this on YouTube and the link will be shared with you guys.
Yeah. Sure. Thank you.